Well, good morning, good day, everybody. It is 5 o'clock in the morning here in very windy Edmond, Oklahoma, in the United States. My name is Alexander Klebanov. I've been a technologist for over 2 decades, last decade, working in data science across the energy industry, from upstream to midstream transportation, refineries, and then downstream and utilities. The last few years in energy industry, we have seen radical tightening of capital markets for energy investment, an absolute roller coaster of hydrocarbon commodity prices. We have seen changes and now we see a new priorities emerging for corporate boards. The sustainability and carbon reduction is at the top of strategic agenda for all companies, and energy transition is changing the buzzwords of digital transformation. So this panel could not be more timely and relevant. The panel title is Digitalization and Decarbonisation and How Data Facilitates the Role of Energy Transition. So we have an excellent panel of speakers for you. First, we have Maan Iskander, who is a Technical Services Department Manager with AramcoOverseas. Maan, would you like to introduce yourself and tell us where you're joining from?
Sure. Thanks, Alexander, and thanks again to Future Oil and Gas for inviting me again for this panel discussion. My name is Maan Iskander, and indeed I'm covering the Technical Services Department, part of AramcoOverseas company, or what we used to call it now Aramco Europe, which is the main subsidiary of Aramco in Europe. I'm calling from the Netherlands, where it's the headquarters for AramcoOverseas company, and it's surprisingly sunny today in the Netherlands, which is unusual. So I've been in the company for 25 years now, and cover different positions in technical and leadership. And I also have the pleasure to manage and be responsible about some mega programs for the company for the location that we have in Saudi Arabia. And I mean, we are all committed toward digitalizations and decarbonizations toward accelerate the energy transition in the industry. And that goes in line with the recent announcement for the company and its ambitions announcement to have zero emissions for Scope 1 and Scope 2 by the year of 2050, which has been recently announced by our President and CEO of Saudi Aramco, which also complements the Kingdom of Saudi Arabia announcement to have net zero emissions by 2060. So I guess it's timely now to discuss topics related to digitalization and decarbonizations, along even the last UN summit about COP26 in Glasgow, where the whole world is united to address and combat climate change. So looking forward for the discussion today, and hopefully we can provide some insights to our audience.
Thank you, Maan, for the excellent introduction and thorough unpacking of the topic. Next, we have Marcio Wagner da Silva, who is a process engineer and project manager with Petrobras. Marcio, do you want to introduce yourself and tell us where you're joining from?
Hello, thank you, Alexander, for the introduction. It's a pleasure here today. It's a great honor to take part of this very interesting panel. I am process engineer at Petrobras, the Brazilian state oil company, and I strongly believe that the decarbonization is a very, very important and fundamental challenge to the players of downstream industry, to any player of the downstream industry, and I believe that is a very, very important topic. Thank you.
All right. Well, welcome, Marcio. Next, we have Neil McCrindle, who is a UK Regional Sales Director with Nasuni. Neil, would you like to introduce yourself and say a couple words?
Yes. Hi. Good morning. Good afternoon, wherever you are in the world. My name is Neil McCrindle. I lead our oil and gas sector here at Nasuni. Nasuni is a global platform that really helps oil companies and service providers collaborate and share data more effectively wherever they are in the world. So a lot of my time is working with operators and service providers and helping them to understand the transition on how they can be more efficient and how they can start employing new data strategies that are going to help their business. So thank you.
Well, welcome, Neil, and welcome all the panelists. So we have quite a few interesting topics and questions queued up for you, but I do encourage all of the audiences to use the chat window to submit your questions, make it relevant to you and your organization, and make it more of a dialogue. So welcome, everybody. The first question we have is, what digital tools and solutions are adopted by your company to monitor carbon emissions and reduce carbon footprint? And I know a few of you mentioned Scope 1, Scope 2, maybe even Scope 3 type collaboration across the value chain. So let's start with Maan and go with that.
Okay, thanks, Alexander. Again, this is really an important question to share with the audience what applications and what tools that we have adopted. I would like to start first by saying that we are really blessed with the evolution of digitalization that will pave the way to accelerate energy transition toward cleaner energy. As Aramco, as a fully integrated energy company, we are pursuing different means to reduce the company carbon footprint, which I believe here is the key indicator when we discuss decarbonization. One of the misconceptions in the industry that the term decarbonization is sometimes linked to the need to introduce alternative energy sources such as hydrogen and ammonia only. While I believe the fact that we need to look at it from a more holistic approach, referencing carbon footprint and carbon intensity as a key indicator. Now, allow me to shed some light and to share with you a few examples of adopted digitalization solutions to monitor carbon emissions and also to enhance energy efficiency with the end results of lowering emissions. So Aramco has developed a carbon monitoring solution called Carbon Footprint Solution, CFS, aligned with the company strategy toward decarbonization, capitalizing on IR 4.0 technology. The monitoring of carbon emission is widely seen as crucial to any effort in order to reduce emissions and thereby slow climate changes. For a fact that the lack of reliable sources of consistent data on carbon emissions is a significant barrier to the efforts for reducing emissions. The developed solution enable the users to identify the main contributors to the CO2 emissions and provide insights on the emissions potential reduction opportunities. So indeed, it helps the organization to prioritize its efforts on tackling the highest CO2 contributors. Aramco has started its journey quite a long time ago in emissions and monitoring from the sources by the completion of Scope 1 and 2 emissions monitoring model. The carbon footprint solution consists of 3 different parts: Saudi Aramco, in-kingdom model, and also the out-of-kingdom model. So when it comes to Saudi Aramco Scope 1 and 2 model, it includes the emissions from combustion, indirect, venting, flare, and fugitives coming from the facilities and from joint ventures as well. While the in-kingdom model shows the emissions and fuel consumptions coming from different sectors with the ability to view the individual's customers' contributions as well. It also reflects the geographical locations of the customers, and the model will also show different set-off or offset opportunities for reducing CO2 emissions. The solution is really a powerful tool which allows the company to observe the emissions generated by each sector that utilize Aramco energy product, hence identifying improvement opportunities. The solution, as I explained earlier, is also developed for the company out-of-kingdom customers. The out-of-kingdom model showcases a worldwide view with the emissions and fuel consumption per continent. And then you can drill down and zoom further to a continental view and to a country view as well. In that view, details of the customers with information about their emissions, product type, and product consumptions are available for viewing. Now, allow me also to switch gear toward one example of recently adopted solution pertaining to energy efficiency. Aramco has developed also an advanced energy demand forecasting solution using machine learning, aligned again with the company's strategy towards decarbonization, capitalizing on IR 4.0 technologies. Basically, the predictive solution, which integrates multiple machine learning algorithms to predict the energy intensity, EI, KPI, which is a corporate KPI that is used in the company. Basically using advanced analytical tools and automation, which eliminates all human involvement. The solution is also a dashboard that visualizes real-time and predicted energy consumptions based on operating critical parameters with an accuracy level of 99%. The visualized gap between the predicted and actual energy consumption will help the user to enhance the facility's operation mode, resulting in an energy efficiency improvement, which is always a key element to reduce carbon footprint. The solution allows the user to run even what-if scenario through an interactive dashboard, where the solution will also be utilized to set a representative energy intensity KPI target. Now, we have a lot of examples to share, Alexander, along with the audience, but I will make sure that the two solutions that I have just described will give at least a general idea about what type of applications that we have with the aim to reduce carbon footprint. I will turn it back to you, Alexander.
Maan, thank you for telling us about the carbon footprint solution and the advanced energy demand solution. I'm, as a data scientist, super curious about the second one. Might have to chat with you offline about it. We are fortunate to be joined by Vaseem Khan, who is a global vice president, digital and analytics lead, NetZero and lower carbon hydrogen at McDermott. We've been having some technical difficulties, so Vaseem, welcome to the panel. If you can quickly introduce yourself, tell us where you're joining from, and then answer the first question too. What digital tools and solutions are adopted by your company to monitor and reduce carbon emissions?
Okay, so good afternoon and good morning, everyone, and I'll shortly explain why we're having technical difficulties. So Vaseem Khan, I'm the Global Operations Head. I also have additional responsibility for digital and low carbon energy, so working in hydrogen, carbon capture, and so on. So very quickly, so McDermott is an energy service provider in terms that we do the engineering, we design, we buy, we build the facilities that, Maan, for example, uses in Saudi Arabia. So we build offshore platforms, we build refineries, and so on. So our contribution, let's say, to carbon reduction is to design facilities which are low in carbon in terms of how they operate. And while we are building these facilities, is to build facilities in a manner that we minimize the carbon footprint, which is our scope 1 and 2 emissions, which become the scope 3 emissions for the operators. So I'm normally based in Houston. When we had the test for this call, I was based in Houston. But now that travel is open, I'm actually calling today from Doha in Qatar, which is one of our key offices in the Middle East. And therefore the slight technical difficulties we were having, because the system I'm using is different from the system that we tested a couple of weeks ago. So my apologies for that. So in terms of McDermott, what are we doing? So, like many other companies in our space, we are committed to reducing carbon, not only in how we design and deliver facilities, but also how we consume energy in our own offices and as our fabrication yards. So as part of our delivery, we own and operate 7 fabrication yards throughout the globe, and which are major consumers of energy. So what is our commitment? in line with a lot of companies and a lot of what we've heard of during COP26. So we are committed to reducing Scope 1 and Scope 2 emissions by 50% by 2030. We are committed to reducing our Scope 3 emissions by 35% for 10 key categories by 2030. So I'll elaborate on that in a little while. We're also committed to zero office waste to landfill by 2025 and a 50% overall reduction in waste generation by 2030. So let's come back to the Scope 3 emission reduction. Now, our challenge, or the industry challenge, is that when we build a large facility, we put tens, if not hundreds of thousands of components together in a very complex manner to produce a facility which will generate hydrogen, it will capture carbon, it will produce gas, oil, petrochemicals, and so on. So what we are saying is that we will delve deep into our supply chain, and we are committed that compared to a benchmark of a couple of years ago, our supply chain, or where we buy from, will have 35% less carbon emissions or greenhouse gas emissions than the base year, which means we'll be buying low carbon steel and so on. Coming to the question itself, so what are we using? You know, I've known Maan for quite a few years, and the challenge of going after Maan is that whatever you say is going to be much, much less impressive than what Aramco and Maan will talk about. So in future, request to future oil and gas, can I always go before Maan goes, so that I have something, you know, which is a little less underwhelming than it's compared to what Aramco does. So what are we doing? The first question is, what do we use? We use a commercially available software called FigBytes to monitor our emissions. Now, FigBytes does more than just monitoring emissions. It also does the analytics for our emissions. So that is what we use to monitor our emissions. It's commercially available. If you Google it, you'll find it. And it's a commonly used software. What we are doing in terms of design is we are in-house and with some software companies developing tools which allow us to not only monitor LNG and petrochemical facility greenhouse gases, but during design stage. So when we are doing early engineering, it allows us to undertake optioneering to determine the best facility or the best way to build a facility. Just to give you a real example, we may have a choice between 3 times 35% capacity compressors versus 2 times 50% compressors, both of which are motor driven. One may be a reciprocating, one may be a rotary. What is the carbon? When we're making that choice, we tend to make it on energy efficiency. We tend to make it on capex. So 2 things we're typically looking at is how much, or will the compressor do the service it's required to do, and how much will it cost? What we're trying to do is to introduce a third variable that by our design choices, how much greenhouse gas is emitted, not only in the normal operating phase, but also during the build phase, in other words, the Scope 3 emissions. So our contribution, let's say, to a low carbon world is to design facilities, to build our own in-house tools, and sometimes work with software companies, engineering software companies, which already do similar tasks. So we can integrate into our design process optioneering or selection processes which allow us to go to a low carbon route rather than just a low capex route or a low opex. One thing I'd like to add here is, before I hand back to Alexander, is that when we use data, we've got to be careful because data needs to be taken in context. And once we have context around the data, that allows us to, it provides us actionable insights, which allows us use of appropriate technology to reduce carbon footprint. So acquisition of data is extremely important, but as important is to ensure that the data is taken in the right context. So with that, back to you, Alex.
Thank you, Vaseem. We're glad you were able to join us, and thank you, panelists, for your answers. It's really interesting to see how between homegrown and commercially available solutions, we're monitoring Scope 1, Scope 2, and even reaching into Scope 3 protocol with the carbon emissions. So moving on to the next question. My next question is, why do service providers and operators have data silos, and what are the reasons and benefits of moving to a shared data platform? So we're going to start with Marcio.
Thank you. Very good question, Alexander. And I understand that the data silos is a side effect of the growth of the companies and departmentalization. And I believe that the digital transformation is can be summarized in one word, is the integration, and the data silos is totally against of this, and this is a very difficult to manage. The data sales is very prejudicial to the companies, and the change of the integrated system is very, very interesting, because we can improve the communication and efficiency, and the the collaboration between the teams. And the data silos is unfortunately, we have some data silos in some companies that can be considered prejudice to the included to the transparency of the companies. Thank you.
Yeah, Marcio, thank you for your answer. I completely agree. Data silos do generate cultural silos, so moving towards eliminating them also promotes collaboration across and really better products and better solutions. So I'll ask the same question of Neil. I know you're passionate about this subject, so keen to hear what you have to say.
Yeah, thank you. So, yeah, I think just to add to Marcio's points, I mean, if we look at why we've had this situation with data silos, and I think a big part of that is the very nature, obviously, of oil and gas companies. You know, we have oil and gas companies, service providers. Their very nature is it's generally a very heavily distributed environment. Most companies have, you know, many offices around the world, and they have users in those offices, of course. So the reason why we have a lot of silos, of data silos, is because the only way in the past, when we look at from the past perspective, to give access to the geologists and the engineers and the users of this data was actually to build infrastructure very close to the users in region, right? You know, we had to build IT, we had to build data storage close to the users, because the only way to give them the performance to do their jobs and for them to access that data was for them to be very close, because somebody touched on this before, networking, connectivity, latency are all things that impact data access. So we had no option but to kind of bring the data to the users, if that makes sense. So that's the legacy of the past. And I think, you know, nowadays, that's we're changing the way that we work. We're trying to move away from obviously that siloed approach, and there's multiple reasons for that. But the biggest reasons that I'm seeing are that innovation's key. You know, customers now are looking for ways to leverage that global resource pool. So they no longer want to have, you know, people in different offices that can't share data. They want to be able to leverage resources everywhere, and they want to be able to access the same data. And that's difficult to do, obviously, if you have silos, because you can't just send a 10 terabyte file across a network, right? It might take days, it might take hours, you know, for that to get across. So we're moving towards this new world, which is an exciting new world. And it means that, you know, we're starting to innovate and look at ways that, you know, we can increase collaboration, and we can make that easier for IT, for example, you know, to put those processes and those platforms in place to enable those users to do their work faster, more efficiently, or with more certainty. And I think those are, some of the key drivers when we talk about engineering workflows, seismic interpretation workflows, and things like that in oil and gas. Thanks.
Thank you, Neil. Thank you for unpacking that. And of course, something my company is very passionate about is creating data warehouses, data lakes. The new concept is data lake houses and eliminating data silos, not just across departments within one organization, but across partners, across maybe even what seemed to be competitors previously through open data exchanges and sharing data securely. So definitely a hot subject in the space. And thank you both for sharing on that. I will ask the other panelists if you would like to add anything. We have a little bit of time. So if you are passionate about the subject, about data silos, and want to add anything, and if not, we will move on to the next question.
So, yeah, if I could just add to what both of the gentlemen said. I mean, I fully agree. The siloization of data is historic. It's because of the way the industry developed, companies acquired companies, systems were not consolidated, and so on. But there is now a very strong economic reason to move away from data silos. It's costing us the hidden cost of data silos or siloization, like the hidden cost of non-standardization, is huge in the industry. It is also preventing us from an HSE point of view. It is preventing us from getting better HSE results because information exists and we can't access it. When you make a mistake once, you'll be forgiven. When you make the same mistake twice, because the mistake was made in your own company, but in another office and you never found out, that is less forgivable. So I think there is a very, very strong economic reason to move away from data silos, and a lot of that is obviously moving to a cloud and moving to a more standardized use, or the nomenclature around data needs to be standardized as well. So as an engineering company, we build 3D models, but the 3D model we'll build for operator A will look very different from operator B because the underlying data, the underlying components are non-standard. So I think, Neil and Marcio, a lot of this is going to be driven purely by economics.
Yep. Yeah, thank you for a very valuable addition, Vaseem. I totally agree. Adding context to data by eliminating data silos give data a new dimension and almost unlimited uses. So very excellent point. So moving on to the next question, we have rapid scaling of analytical applications is able to lower operating expenses and increase operational runtime and decrease carbon footprint. So we will start with you, Maan, if you would like to answer that.
Yes, definitely. And again, we are really blessed with, different technology and solution providers. The thing that I'm going to discuss here, some of them are solutions and analytics that have been developed in-house by the capability of our data scientists and our experts in different fields. And some of them are from technology and solution providers. But basically, I would like to say that, data analytics and analytics applications have a major influence on the oil and gas industry. This industry depends significantly on data to operate and improve its processes. This industry also has a growing reliance on data and always has a need to move frontiers in the research and production process, which guarantee the importance of state-of-the-art analytics in the oil and gas business. Those can come with different and multiple objectives, basically to ensuring human safety, reducing production costs, predictive and preventive maintenance. Now, I would like really to shed light on two analytical applications on our upstream sector. First, our North Ghawar field, which is located in the eastern province of Saudi Arabia, produces Arab extra light and Arab light crude from three major areas called Abqaiq, Ain Dar, and Shadgam. All are located again in the eastern province of Saudi Arabia. And they are run through 15 gas, oil, and separation plants, or what we call them GOSPs, to separate, of course, crude from water and gas. You know, a large number of wells for oil production and water reinjections are distributed across the entire field. The production network has been enhanced with several swing and transfer lines to increase operational flexibility among separation plants. Now, on top of that, a rigorous optimization platform was developed for North Ghawar GOSPs by again capitalizing on the I4.0 smart solution with the objective to optimally distribute the feed to different plants under different operational scenarios. So basically what we are saying is the objective of this smart solution is to optimize the number of running facilities by shutting down facilities with high energy consumption based on set target in that specific month, because all depends on the demand. Maximize also asset utilization, optimize operational expenditure, and reduce greenhouse gas emissions. On the other hand, we have our Khurais facility, the largest intelligent oil field in the world, which is also being recognized by the prestigious award by the World Economic Forum, Lighthouse for Digitalization, as one of the 3 facilities that have been recognized. This facility is equipped with industrial Internet of Things devices and digital twin technology, which enables remote operation using real-time 3D virtual reality software to optimize the operation of the field and reduce carbon emissions. The site connects big data analytics, machine learning, smart sensors, and a remaining useful life forecasting system. The oil field makes use of an advanced process control system for smart production rate adjustment, while 2 patents have been received for a smart performance monitoring applications that uses predictive and prescriptive analytics with the objective to optimize fuel gas in boilers, contributing to fuel gas savings and reducing CO2 emissions. The digital twin that is being used by operations in the control room is to keep an eye on end-to-end operations to monitor, predict, and diagnose. Advanced algorithms can be released to stop, reduce, or start or increase the intelligence field operations. You know, these advanced technologies have resulted in the reduction of overall power consumption at Khurais field by 18%, and also reduced maintenance costs by 30%, and cut inspection times by 40%. In addition, these technologies have enhanced reliability, which is again a key factor, by 50%, and increased operational response times by 100%. Operators now can make decisions based on information obtained through real-time IoT controlling systems. You know, each well in the Khurais oil field is equipped with smart downhole sensors, inflow control valves, and electric submersible pumps. Through big data analytics and machine learning, producing oil and gas from the wells is less energy intensive, and possible failures are better identified in advance, and reservoir management is enhanced. So I'll conclude by saying that using machine learning, predictive and prospective analytics, Khurais developed its own system to optimize fuel gas in boilers, and the application contributed to significant annual gas savings and 8% reduction in CO2 emissions. Those are some of the examples, Alexander and the rest of the audience, for some of the applications for the rapid scaling of analytics, specifically in the upstream sector, where I'm also glad to share that when we discuss about carbon intensity and specifically upstream carbon intensity, we are among the lowest compared to our peers in the industry. And back to you, Alexander.
Maan, thank you for that answer. Very impressive solution. Great metrics, down 18% power reduction, 30% maintenance cost reduction. Really impressive approach to being proactive rather than reactive to your consumption and carbon emissions. So the same question for Vaseem. Talk about the rapid scaling of analytical applications and lowering operating costs and expenses, and increase operational runtime and decrease carbon footprint.
So we obviously view it from a slightly different angle, since we are not an operator. We design and we build facilities for typically for 25, 30, 40 years. So having said that, I mean, artificial intelligence, analytics, machine learning is most definitely a game changer. I don't think there'll be too many doubters, at least on this panel and this audience, on that. You know, it has the ability to deliver, you know, deep insight into our carbon footprint. It will identify, it will bring, you know, it will bring to the fore where is the carbon being used. It will also then learning how carbon emissions are changing in the course of a day, in the course of specific operations, in the course of the environment outside. I mean, it will, much better than humans, be able to come to a conclusion, let's say, of what conditions have to exist for the lowest possible carbon operation. And, you know, as Maan was saying, it may be something like shutting down the high energy producers. It may be, you know, operating on a different source of power during a different time of day if you're in the US, or if you're in Europe and you've got choice between power users. The challenge, of course, is that what we are trying to do is to mitigate carbon from existing operating facilities. The challenge, of course, is if you're trying to meet the COP26 numbers, that's clearly not enough. Which means that the facilities which come on stream now, or designed and built now, have to have a much, much lower carbon footprint. And our challenge is, how do we use data collected over the tens of years we've done projects, and to find an optimal point, which is between capex, carbon emissions, to design a facility. Because, you know, Alexander, it is relatively easy to monitor emissions. It is relatively straightforward to predict emissions. It is not so simple and not so straightforward to reduce emissions. Now, the obvious solution is, let's move from gas turbine to electric drive machines, for example, or let's put in better seals on our compressors, for example. But, you know, and those solutions all come with a cost. In terms of electricity, you need to know the source of your electric power as well. So where data, where analytics, we believe, will play a part, is our ability to design facilities which are lower, significantly lower greenhouse gas emitters than facilities are today. And that is not just, you know, analytics, but it is also using advanced computing power to design facilities which operate on the edge rather than somewhere in the middle of their operating you know, I don't want to sound like a cynic, because I am a believer in all of this, but the sort of things we need to do to be able to achieve the reductions that we're talking about in COP26 is a multifaceted solution. It's not a solution of analytics or AI alone. It's a solution that involves changing the way we build things, changing our work processes. It involves changing our supply chain. So rather than buying steel produced the traditional arc furnace way, we will have to look for steel produced in the less traditional DRI, the direct reduction route, using power which is renewable and using as a heating source hydrogen rather than natural gas. This is not going to happen overnight. This is not going to happen in the next 10 years or so. But that is where analytics is going to play a role, is to help identify the lowest carbon. There is going to be a sweet point between capex and carbon emissions, and that is what we have to identify. And that is where analytics is going to play a really good role. So with that, back to you, Alexander.
Vaseem, thank you so much. I totally failed to let you speak before Maan, but you did great. Thank you for all this information, and I absolutely agree with you. I think reaching further and further into supply chain and designing and building facilities more intelligently definitely has a much bigger impact on reducing carbon, which, going back to previous question about information silos and sharing across the supply chain really will affect that. Anybody else would like to speak up on the subject of scaling analytical applications to reduce carbon footprint? All right, we will move on to the next subject. There's a lot of disruption in transportation and auto, even in aviation fuel. So I would like to ask you all to discuss the technologies that have a potential to disrupt the dynamic of traditional transportation fuels, like electric vehicles and sustainable aviation fuel. Marcio, would you like to discuss that, please?
Okay, thank you, Alexander. We are seeing the last years controversial scenario for the transportation fuel demand, and especially related with the stricter regulations and the necessity to establish a real low carbon economy. And we have some increments in this scenario: the electrification of fleet and the new patterns of the mobility in the post-COVID scenario. And we have some interesting and important technology that have potential to destroy or reduce the demand for transportation fuels. For example, the additive printing, the drones, and the electric vehicles. It's always important to remember that these are incremental changes. We are we not nowadays we don't have available clean technologies to promote disruption and the transformation, the transportation fuels demand, but it's possible to see incremental change that are make moving the players to another production focus. For example, the petrochemical integration, the downstream industry is a trend, a very important trend. We are seeing a very large capital investments in more integrated petrochemical plants and refining plants. For example, we have around 300 billion dollars US dollars in crude to chemical refineries, especially in the Asian market, that reveals the change in the downstream market. This is a very interesting, and I believe that the new technologies and the pressure to the decarbonization of energy metrics are among the drivers of this capital investment and this change in the downstream industry.
Excellent. Thank you very much. I open this to the panel. Talk about the potential to destroy traditional transportation fuels demand like EVs and sustainable aviation fuels.
Alexander,
Again,
I would like to
Alexander,
comment here.
concept over time rather than immediately. I mean, I think hydrogen fuel cells is for long distance transport, and I know Aramco is working on that as well. Hydrogen fuel cells have a good potential. They are truly, if hydrogen is produced through the electrolysis route rather than blue hydrogen route, that is truly net zero in that it's very clean. Electric vehicles are clean, except depend on where the source of electricity is coming from, right? I mean, it's when we say that we haven't reduced it if the electricity is being supplied by a coal plant which has no post-combustion CO2 capture. We've moved the problem from one place to another, but we've not made the problem go away. All of the vehicles, all of the products that we use today still have high carbon intensity into it. So again, unlike what you see in the newspapers and on television, there's no easy solution. But hydrogen fuel cells, I'm actually quite bullish on hydrogen fuel cells. Synthetic aviation fuels, I know a lot of companies and a lot of airlines are funding research into this, and I know, there have been a couple of commercial flights, but the volume of fuel that is required and the ability to distribute the fuel, because you can't commingle you can't commingle synthetic fuel with the normal jet fuel, JP6 fuel. So the ability, the infrastructure to be able to supply segregated fuel is going to take a bit of while to do. But again, fuel cells and electric vehicles using renewable power.
Yeah,
Excellent clarification. Maan, please add some. Yeah.
Yes, I tend to agree with Vaseem and Marcio. I mean, just like quick 2 points. I mean, one point earlier highlighted by Vaseem is that we need really to strike a balance between capex and emissions control. And again, when it comes to the transportation sectors, which is an important sector when it comes to fuels and alternative fuels and future energy mix, I believe that the industry should be open to different kind of alternatives. Sometimes in the industry, you look at it as that it's a matter of a race or a competition, that we shall go ultimately to AVs or to hydrogen fuel cells. Where I believe that the key factor here is that to measure exactly the carbon intensity, how much we are reducing those carbon emissions or greenhouse gas emissions, rather than just shifting the entire world into the transportation sector toward just one source of energy to be used as the major source of energy for the transportation sector in the future. I guess the energy and the industry should be open for the diverse use of different applications and different technologies.
This is excellent content. Thank you, everybody. And I have one more question. What technologies support transition to data sharing? Neil, I'd like to ask you that.
Sure. Yeah. I mean, when we look at data sharing, as we touched on before, a lot of it is still siloed, and I think that the fundamental change that needs to happen to enable data sharing more effectively is to centralize the data. Really, is to try and move away from having data scattered around all these silos and being able to centralize it in one place. And that means that the data can then be presented out to the users, out to the edge, as I think Vaseem talked about it. The edge is key because that's where our users, the people that are going to be analyzing the data, are based. And again, a point I'd like to make is that we talk a lot about there's so much technologies out there on AI and analytics, and these are fantastic technologies. But obviously, they're only as good as the access to that data, right? So we can have the best technologies in the world, but if we don't have a platform that enables us to access that, then it undermines that ability there. So I think what I'm seeing generally in the industry is I'm seeing companies that are moving towards cloud platforms, public cloud platforms like Google, like AWS and Azure. They're looking for ways to centralize all that siloed data, and then use file technologies such as ourselves or others that enable customers to access that data locally, so they can access it locally, and they're not impacted by historical issues of bandwidth and latency and all those sorts of things. Now, that's obviously an IT problem. That's an operational challenge that we're trying to overcome because we're making the data accessible. But if you look at how the industry is changing as we react to COVID and fluctuating oil prices and the need to be more flexible, it's not just being more flexible in the technologies, but it's being more flexible in our approach and being able to try and standardize the protocols that we use across the board. Having a common platform, having a platform that enables us to scale, because there's so much acquisition activity within the market now. It's becoming a lot more changeable. We need to have something that enables us, gives us that dynamic. And I think that the last point to that around the data is when we're accessing it, if we ever, we need to think about data protection. How do we protect that data? And I think that's the key thing. We saw the Houston terminal being cyber attacked. Many of you will remember that back in May. So the impact of these things is becoming greater and greater. It really is, and it's looking at technologies that allow us that fast recovery without the operational overhead, but equally giving us the outcomes that that we're looking for in the short and the long term.
Yeah, Neil, you bring up some really good points. Standardization and protocol is definitely a struggle across many industries. Even in carbon sharing protocols are needed. You see things like open subsurface data universe emerging, but kind of not taking off as fast as we wanted to. So there's still some siloed thinking and lack of collaboration across partners and maybe across players in the industry. Anybody else would like to add to data sharing challenges we're facing?
If I could just quickly to your
question. Sorry, Neil.
Oh, you go ahead, Vaseem.
I was actually going to ask you a question, Neil. One of the arguments I hear in where I work is that, yep, centralization, creating this big database is a good idea, but one of the advantages of having, they don't want to call it a silo, but let's say segregated databases, is that you don't have a single source of failure. You don't have a cyber attack which will bring the whole company down, because the data is probably repetitively stored in multiple places. But what would you say to that, Neil? To that argument?
Yeah, so I mean that's a really good point, and I completely agree. There shouldn't be a single source of failure. I mean that is an absolutely valid point, and the whole idea with moving your data into cloud platforms is there is no single source of failure, right? Because if the data is in a data center in public cloud, for example, there's going to be multiple copies of that data. In a lot of cases, it will be replicated to different regions around the world. So you've got data resiliency. If there's a corruption or a cyber attack, you do have the ability to maintain data integrity. But equally, the old world, we bought, two storage systems, or we backed it up, and we had all these different silos. And the challenge with that is, if you back up corrupt data, then you've still got corrupt data. So, that's where that old argument falls down. So it's really, I think when we look at, if I use an example, if we talk about things like seismic interpretation or seismic data sets from Schlumberger and others, you may want to recover those files, to the point where it wasn't corrupted, right? So having a platform that allows you to go back further in time is also a key part to that, because then we can recover to the point where we know that file was in a good state. So a lot of it comes down to resilience and scale.
Yeah, excellent point, Neil. And I do agree, with globally scalable cloud platforms, you're replicating data across regions. There's also some regulatory requirements a lot of the times in our industry that, we're viewing the data as an asset, and so some of it need to be stored in particular jurisdictions to satisfy regulations. And one other point I wanted to add, monitoring data not just at the time of consumption and analysis, but really at the time of ingestion, at the time of storage, kind of helps you catch some of those data problems early, so you don't get into this problem of replicating erroneous data. So definitely some tools and methodologies there. So we really have a few more questions, so I'll just go on. I don't see any questions from the audience. Again, I encourage the audience to use your chat window, and we will see them here. Next question is, how is the application of digital technologies changing with energy transition? Vaseem, you get to go first.
Okay, thank you. Well, when we tell people, and it might sound a little facetious, the difference between the traditional energy, the traditional oil and gas industry, and the energy transition or the new energy industry is that the oil and gas industry is a digital convert. We come from a background of analogs, of using clipboards, walking down, taking data, entering that data into an Excel spreadsheet. That is our background. The energy transition industry, because it's a much newer industry, think of them as the teenagers, let's say, of the industry. They have grown up with technology. They are at home. They are digital natives. Yeah, they have grown up using tablets. Their form of communication is very different from a traditional form of communication. I've got a son who just left college, university, and we were doing a study internally, and I asked him, what is the ratio of emails that you send compared to using other forms, chats, iMessenger, and so on? And his response was very telling. His response was, Dad, we only send emails to old people, right? Which obviously was stress to me. But because email is a one-way communication, you wait for the response, whereas the chat function is much more flexible. So that is the difference between the traditional oil and gas industry and the energy transition industry. The new industry will do things differently. They will do things on the basis of technology built in, as opposed to technology bolted on. And I think Neil probably understands what I'm saying. It's because when you build it from the ground up, you'll build it differently than if you have to modify it. And that's the thing. It's, you can put an electric engine in a traditional oil and gas car. It is done. There are, my favorite car, the E-Type Jag, but there are now E-Type Jags available which have electric engines in it. But if I were to take a typical petrol car and put an electric engine in it, it would not be as efficient as a car built for an electric motor. That's the difference, in my opinion, is that one is a digital native, the other is a digital convert. And the attitudes and the approaches are quite different.
Yeah, that's an excellent point, and I also can't keep up with all the platforms that my kids are using, so I'm in the same boat. I like what you're saying about digitization and how the new generations are bringing that perspective into the influence of first the workforce and now entering the corporate boards, not just the consumer sentiment, but really influencing the industry from the inside, and digitizing, viewing digital as a process rather than digitizing inputs and outputs of the process, like the analogy you used with a gasoline car with an electric engine. So really great analogy. Anybody else would like to add to the perspective of digitization in the energy transition space?
Yeah, I was just going to add to Vaseem's point. I think overall, I think it's an exciting place for oil and gas and energy in general because oil prices are high right now, but we've seen some changes over the last few years, and for me, I think because of the challenges in the sector, that has also driven innovation. It's forced us to look at new, better, more efficient ways of doing things, and of course, the new generation are excited by that in terms of their approach and how they're used to digital technologies. And we use the word in our sector. A lot of it is about being cloud native. So to Vaseem's point, having technologies that are born, with these types of things, rather than trying to adapt the old world and trying to modify it, where maybe it's not right. Maybe we almost we need to wipe the slate clean and say, well, hey, if we were doing this from scratch, we're in a completely different environment now. We're in a different landscape. We're in a different geopolitical environment. All these things have changed. So maybe it's time to start looking at things from the ground up, as opposed to, and I think that in itself, that attitude, that approach generates new ideas. You talked about OSDU, being able to share data with OSDU, for example, and I think that's an area that will take off as well.
Yeah, excellent point. So we are almost at time. Everybody, I really enjoyed the discussion. There's some really excellent content and information brought up. I like the discussion where, as we keep measuring carbon footprint, we're measuring sustainability, we're running into bottlenecks, reaching further and further into kind of supply chains, and then starting to design facilities, sourcing not just equipment, but even the raw materials. Some of you mentioned, low carbon steel or low carbon raw materials in designing our facilities. So definitely very, very ambitious goals and results that your organizations have shown over the years. And thank you for enlightening us and sharing all this information. Any last thoughts, any last words? We're about a minute away from closing time. Excellent. Well, gentlemen, it's been a pleasure speaking with you and leading this discussion, and I hope we meet again at a different conference.
Thank you.